The cetane number of a diesel fuel is critically important to combustion. But how does it really impact what is going on in the engine? Gasoline engines are often called spark-ignited engines. In these engines, a mixture of fuel and air is normally pre-mixed in the intake system before entering the combustion chamber. A spark plug is then used to time the combustion for optimal performance. Diesel engines are often called compression-ignition engines, and the process differs from their gasoline counterparts in several significant ways. In the diesel engine, air is brought into the combustion chamber through the intake system, often at boosted pressures thanks to turbocharging. As the piston rises, the air is compressed to much higher pressures than in gasoline engines, thanks to the higher compression ratio of the diesel engine. To properly time the start of combustion in a diesel engine, we rely on the injection of the fuel directly into the combustion chamber that now already contains hot, high-pressure air. Instead of a spark, it is the dynamics of the highly compressed air that is sufficient to initiate combustion when the fuel is sprayed into the cylinder. However, in reality, the combustion does not start instantaneously. There is a relatively short delay between the initial injection of fuel and the start of combustion. This time delay, or ignition delay, between the initial injection of fuel and the start of combustion is essentially the effect of the cetane number of a diesel fuel. Fuels with higher cetane numbers have a shorter ignition delay and combustion begins sooner. As a general rule, these fuels offer better engine performance. This can lead to easier starting, less white smoke on startup, less noise, and lower emissions. All diesel fuels have a given cetane number from their basic formulation, but often, fuel marketers use cetane-improving additives to increase the cetane number and further enhance the performance benefits of their fuels.